Hey guys, welcome back. So today we're going to be talking about stats topic 2, which is theoretical and experimental probability. Now, before we start, we do have some definitions that we need to go over to make sure that we help clarify our understanding of the topic. Now, a lot of these in our stats and probability, the biggest thing is to not overthink any of this. Just try not to overthink it and you'll be okay. So first off, an outcome is the result of a single trial. Your sample space would be all possible outcomes, so anything that is possible. And an event is any outcome or group of outcomes. So you need to pause this and copy it down. So how do these relate to rolling an even number on a number cube? So a number cube is just your standard 6-sided die. So here, your event would be rolling an even number. Your sample space, remember, is all possible outcomes. So if I'm talking about rolling a standard, rolling on a number cube or a dice, we could roll a 1, a 2, a 3, a 4, a 5, or a 6. And then your favorable outcome would be your even numbers that you could roll. So that would be if we rolled a 2, a 4, or a 6. Now, your probability of an event, which we denote as P and then whatever the event is, we would write it out, tells you how likely it is the event will occur. The probability of an event tells you how likely it is that the event will occur. Your theoretical probability, so how we would find our probability, is that the probability of an event is the number of favorable outcomes divided by the number of possible outcomes. So the probability of some event happening is the number of favorable outcomes divided by the number of possible outcomes. So if we go back to our rolling an even number, so the probability of rolling an even remember, this is again on a standard number cube. Number of favorable events. So how many even numbers are there? Well, our favorable events are 2, 4, and 6. So there are 3 favorable events, or 3 favorable outcomes out of our number of possible outcomes. So that's our sample space. So there are 6 possible outcomes. So the probability of rolling an even would be 3 out of 6. Or if we reduce this 1/2. Now we could write this as a decimal, a fraction, a percent. Any of them are okay. So we can write the probability of an event as a decimal or a fraction or a percent. Now the probability of an event ranges from 0 to 1. So 0 means it's impossible to happen. 0.5 means it's equally likely to happen and not happen. And 1 means that it is certain to happen. So some examples here. Again, we'll go back to our standard number cube. The probability of rolling a 7 on a standard number cube is 0 because it's impossible to happen. However, the probability of rolling a number that is less than 7 is 1 because all of the numbers are less than 1. All right, problem 1. Our solar system's 8 planets in order from least to greatest distance from the sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. You will randomly draw one of the names of the planets and write a report on that planet. What is the theoretical probability that you select a planet whose distance from the sun is less than Earth's? Now, if you're using your PowerPoint notes, you may need to write this above or below the slide. There's not really any room on here, so I'm just going to go to a blank slide to work this out. All right, so we are trying to find the probability of picking a planet whose distance is less than Earth's. So we need to find how many planets have a distance less than Earth. Well, there are 2 planets that have a distance less than Earth's. That would be Mercury and Venus. You don't have to write down the Mercury-Venus part. Divided by all possible planets that we could have pulled, which would have been 8. Because there's 8 total planets. So we would reduce this. So we would get 1/4. Now, if we wanted to write it as a decimal, you get 0.25, or a percent would be 25%. I generally prefer the fraction or the percent, but any of these would be okay. However, make sure if you're writing the decimal or the percent, you're showing whatever fraction that you started with to get that. Now, it's not written, but I'd like you to try. 1. I'd like you to find the probability, the theoretical probability, of choosing a planet whose distance is greater than Earth's. So pause the video and try this one. All right, you should get 5/8 or 0.625 or 62.5%. Because there are 5 planets whose distance is greater than Earth's. Mars, Jupiter, Saturn, Uranus, Neptune, out of our 8 total planets. So now we're going to talk briefly about the complement of the event. So a complement of an event consists of all outcomes in the sample space that are not in the event. So it's kind of like the opposite of an event happening. And we have some notations for this. So sometimes you'll see like a squiggly line in front. So the complement of A. Or you can see it as an apostrophe. Or you might see it as like a little C up there. These are all just different ways to denote the complement of an event. And basically, how you find the complement is you have to consider what is the probability of something and not something happening at the same time? So my example I use, what's the probability that it rains or does not rain? And that should give you 1. It either is going to do something or it isn't going to do something. So to find the probability of an event plus the probability of not that event happening too should equal 1. And remember, the not event is the complement. And that's generally what we're trying to find. So the probability of not an event happening would be 1, or 100%, minus the probability of the event. So in a taste test, 50 participants are randomly given a beverage to sample. There are 20 samples of drink A, 10 of B, 10 of C, and 10 of D. What is the probability of a participant not getting drink A? So the probability, and again, you can write outside of the little boxes if you're using the PowerPoint notes. It's just hard. The way that this scans into the system, it does not let me write outside the box. So the probability of not getting A would be 1 minus the probability of getting drink A. Well, the probability of getting drink A would be 20 out of 50, because there's 20 samples of drink A out of a total of 50 participants. So 1 minus 20 over 50 would be 30 over 50, which would reduce down to 3/5. Now, because it does give you drink B, drink C, and drink D, we could add those together and get the same thing. But the purpose of this problem was to use the complement. All right, so we're going to switch briefly to odds real quick. All right, odds. So your odds of an event happening is slightly different than the probability. So if you've ever kind of looked at how the most frequent area I can think of is kind of in sports betting or horse racing, the likelihood somebody's going to win is generally given in odds instead of in the probability. So we have 2 odds formulas that we'll talk about. We have odds in favor of an event happening, and the odds unfavorable would be comparing the number of favorable outcomes to the number of unfavorable outcomes. So this is a little bit different than probability, as in probability, we would compare the number of favorable to the total possible instead of the number of unfavorable. Now, sometimes it might ask for the odds against. And the odds against an event happening would be the number of unfavorable to the number of favorable. Now, sometimes you might not see these as fractions. You'll see them kind of as ratios. So we could see something like a number and then ... another number. Or some number ... another number. Or you could write it out. You could say some number 2, some number. So let's go ahead and do an example. Problem 3. And again, you can write out on the outside of it. What are the odds in favor of the spinner landing on a number greater than or equal to 6? So odds in favor. So you have to pay attention to what it's asking. So we're going to use our odds in favor formula. So the number of favorable to the number of unfavorable. So the odds in favor to landing on a number greater than or equal to 6 would be the number of favorable outcomes. So the number of times I can land on something greater than or equal to 6 to the unfavorable, so the not greater than or equal to 6. So when I look at here, I have 1, 2, 3 that are greater than or equal to 6 compared to the number that is not greater than or equal to 6. So that would be 1, 2, 3, 4, 5. So here I have 5. I can't reduce this. Now again, we don't necessarily write these as fractions. We would write it as 3 to 5 or 3 to 5 ratio. So go ahead and pause the video and try the U-try. Please notice that you're doing the odds against. Okay, so make sure you use your odds against formula. So pause the video and try this one. All right, check your answer. So we have a 3 to 1 odds against landing on a number that is less than 3. So how many are not less than 3? Well, that would be 3, 4, 5, 6, 7, 8. So there's 6 options we could have had over the numbers that are less than 3, which would be 1 and 2. And the last thing we'll kind of talk about is experimental probability. So your experimental probability is slightly different than your theoretical probability. Your experimental probability is based on data that's collected on repeated trials. So based on an actual experiment, not just in theory. And the probability of these events happening is fairly similar. So how we find this is the probability of some event happening is the number of times the event occurs divided by the number of times the event is done. Number of times event occurs divided by the number of times the event is done. So if I'm talking about, for example, rolling an even number again, we'll use that on my standard number cube. In theory, it should land on an even half of the time. But based on an experiment, it may not be 1/2. It may be something close to 1/2. So for example, if I flip a coin 5, or I roll a die 5 times, it should, in theory, land on an even half of it. But it might land on an even 6 out of the 10, or 4 out of the 10. Okay, so that's the difference between theoretical and experimental probability. So problem 4. After receiving complaints, the skateboard manufacturer inspects 1,000 skateboards at random. The manufacturer finds no defects in 992 skateboards. What is the probability that a skateboard selected at random has no defects? Write the probabilities in percent. So the probability that we have no defects well, there were 992 skateboards that had no defects out of our total of 1,000. And it wants us to write this as a percent. So when I divide these, I'll get the decimal. So 0.992. Move the decimal point over, so this will be 99.2%. Right. We can use experimental probability to make predictions. Predictions are not exact, so we can round our answers a little bit. So answer 5, we ask 500 randomly selected households in your town if they have a dog. Of the 500 households, 197 respond that they do have a dog. If your town has 24,800 households, how many households is it likely to have a dog? So what happens is 24,000 is way too many, not way too many, is a very large sample to try and ask every single person. So what we'll do generally is we'll ask a smaller subset of those people to find the probability, and then we will translate this probability into terms of our population. So again, there's not enough room really. I'll write it up here. So first I want to find the probability that somebody has a dog. So based off our sample, 197 out of 500 households had a dog. Now I could change this into a decimal if I wanted to. But if my town has 24,800, what I'm going to do is I'm going to take this probability and multiply it to 24,800. So once I get whatever decimal that is, I'll multiply it. So I should get something close to 9,771.2. Can't have 0.2 of a household. So we're going to round this to 9,772. Now, it could be slightly off depending on how you rounded it. All right, so the last problem, try the U-Try. A manufacturer inspects 700 light bulbs and finds that 692 of the light bulbs work. There are about 35,400 light bulbs in the manufacturer's warehouse. How many of the light bulbs in the warehouse are likely to work? So pause the video and try this one. All right, so this one, there's a couple answers that I would have accepted. So how we do this, the probability that the bulb works, there's 692 out of 700 that work. I'm going to take this probability that I got here and multiply it to 35,400, which should give us 34,995.4, which we would round because we can't have 0.4 of a light bulb, so we'd round it up. So this is technically like our most correct answer. However, this is an ugly decimal. So if you rounded it somewhere before multiplying, you would have gotten, depending on how you rounded, any number between 34,692 and 35,046. So as long as your answer is somewhere in there, I would accept it. All right, and that's all for the notes for